In this video, I will find the capacitance, the magnitude of the electric field, and the amount of energy stored in this parallel plate capacitor. So here I've redrawn the scenario and made a table of knowns and unknowns. I know delta V, D, and A for this parallel plate capacitor. I'm looking for the capacitance, the electric field inside, and the amount of energy stored in it. So the capacitance, C is epsilon naught A over D. Epsilon naught is the permittivity of free space, so I just need to look that up. .85 times 10 to the minus 12 coulombs squared per Newton meter squared. Multiply that by A. A I converted to square meters. Don't forget, you have to convert centimeters to meters twice to do that. So 0.002 meters squared divided by D, 0.001 meters. So this is 17.7 times 10 to the minus 12 something. Crazy units. Coulombs, newtons, all this stuff goes together. If we kept all of our correct units, then the unit for capacitance that will come out of this is the farad. Rarely is any number given in farads. It's usually given in some smaller units. 10 to the minus 12 is pico. So this is 17.7 picofarads. All right, so that's C. How about E? Parallel plate capacitor inside the E field is constant. So I know that delta V is minus E times delta X cos theta with the absolute values in there. And it's only asking for the magnitude of the E field, so I don't need to concern myself with the minus sign or the magnitude signs. The cosine data, the E field runs the same direction as the distance D that we're going to deal with, so we don't need to worry about any of those. All we have is E is delta V over delta X, because all the signs went away and the cosine goes away because the angle is 0. So E is delta V over delta X, or in this case the delta X is just D. So this is 12 volts over 0.001 meters. So $12,000 volts per meter. Volts per meter is one of the two valid SI units for electric field. Remember, the other one is newtons per coulomb. So 12,000 volts per meter, or you could call it 12 kilovolts per meter. So that's E. And then UC, the electric potential energy stored in the capacitor. We can have QV over 2. Do we have Q? We don't have Q, so I want to try to avoid that. We also have the option of C times V squared over 2. C we have, and V we have. So that one I'll go with. C times V squared over 2. So that is, I'm going to go back to here, 17.7 times 10 to the minus 12 farads. V squared, that's this 12 volts, over 2. 1.27 times 10 to the minus 9. And units on this is energy, so joules. And there we have it. C, E, and UC.